Okay, these, I'm going to start coming by a stamp, but I'm going to check your boxes. So let me just make sure. Yeah, put the phones away, please. Now, we might need to add a couple things. Today I'm going to check, I'm going to give you back your checks that we did last Friday, but we're going to make sure we can follow our steps. First thing, you need to always mark your diagram based on what's given to you and based on what you know. So mark it with given information, add on here also, and known facts. Okay, mark what's based on what's given and also your known facts. Rewrite the given as your first step. Your given should be as your first step. Look at shared sides to use a reflexive property, shared sides or shared angles. So when we're using reflexive property, we're going to do shared sides or angles. Find words in the given so that you can do definitions. Midpoint and bisector are the most common words that they give you. Also, find symbols that are given. That means the figure's already marked for you. And then mark your right angles congruent and parallel alternate interior angles congruent. We're going to practice making sure we can mark given information. Make sure you look at your marked up diagram to look for a 3-letter theorem. Once it's marked, we're trying to use our 3-letter theorems. What are examples of that? Yeah, there we go. ASA, angle, side, 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 angle, side. What else? Yeah, angle, angle, side, and HL. Okay? We're going to use these 3 letters to basically prove the triangles are congruent. If you prove, then you can do CPCTC. If you prove it, then you can use CPCTC. You have to prove it first. And that's what I'm going to check that we can do. Get to step 8, basically. All right, so here's what I'm going to do. You have to have 7 box complete. This first row is dealing with sides. So the key word here says M is the midpoint. So you have to mark it on the diagram. It was the midpoint of KL. How would I show it as a midpoint? Tick marks. If I know it's a midpoint, what conclusion can I draw from this? KM is congruent to segment ML. What would be our reason justifying that statement? Definition of midpoint. Yes, so if you have a term that's given to you, notice that has to be given, then you can use your definitions. All right, what's here? If I want to show AB, or BD, excuse me, bisects AC, how would I show bisecting? Yep, tick marks on AB and BC. So what conclusion can I draw from this? Yeah, AB is congruent to BC. What would be my justification, my reason? Definition of bisector. Not an angle yet. We're getting to that one. We're getting to angle bisector. Yes. No, right now we're just drawing the conclusion. Okay. All right, and then reflexive property. We want to use the reflexive property. Reflexive property is used with what? When do we use reflexive property? Shared sides or angles. Okay, do we have a shared side? Yeah, so we're going to write or show that shared side as a reflexive property. JL is congruent to JL. Or you can say LJ. But it has to be stating the same side. All right, so that's sides. This next section, all of this is making statements about angles. This is for angles. So, where would we use the reflexive property for angles in this example here? I need an angle. Okay. Angle B. So angle B is in this triangle here. right? And in the other triangle, yes. Okay, so I could say angle B is congruent to angle B, okay? Or I can name it with three letters. Just make sure you know if you use three letters, the B has to be in the vertex. So I could say angle CBD is congruent to angle ABE. That's the same thing, because sometimes you have to use three letters. But a shared angle, yeah. Yeah, this angle right here is shared. So that's why it's reflexive. Okay, so we have, now you're going to give me right angles. You need to name the angles with three letters for angle bisector and name the angle with three letters for vertical. I need to finish these boxes using what it says. So if I'm right angles, if it says right here, we're using, if it says we're using right angle theorem, then I need to have a conclusion about right angles here. If I'm doing an angle bisector, we need a conclusion about that. Vertical angles, you should list vertical angles. I need you to finish, and then corresponding, those are your hints. Whatever they name it or identify it as, that's your hint of what you should be drawing your conclusion as. So I'm going to give you some time because I need to do row. I forgot to do that. And then I'm going to come by and check that you have at least 7 boxes complete. Yes. Oh, okay. Yeah, hold on. Okay, guys, the order guys, the order can change, be different, but what must occur is that D, which is the vertex, has to be in the middle of the order that you use. So same thing with vertical. We can't just say angle P because there's actually 4 angles that have the vertex P. So that's why we need to use 3 letters to name that. So you can have a different order, but the P must be in the middle. Alternate interior angles, that is the angle formed with the parallel lines, and you might need to do this to help you see it. Extend your lines that are parallel, and then look for your transversal. We actually have 2. There's 1. And so I could say, some of you wrote angle S is congruent to angle T, which is fine. Or you could say QTS is congruent to RST. Okay? 3 letters. Sometimes it takes 3. All right, so the transversal actually, extend my parallel lines. Our transversal is the DB. So my alternate interior angle is the angle formed by that parallel line and the transversal. So some of you wrote angle B and angle D, but there's more than one angle with the vertex B and D. So angle ABD is congruent to angle CDB. I did angle. No, angle. Symbol. Corresponding. Extending the line sometimes helps you see, so I'm just going to continue to do that. Where's the highlighter? Oh. All right, so here are the parallel lines, what the arrows are. The transversal, what segment represents the transversal? Where's the transversal? Not VU, no. ST is the transversal. ST is the transversal. You might need to color code it so you can see it. So the corresponding angles have to be formed with the parallel line and the transversal. So that should be, some of you just wrote S and U. Angle S is congruent to U. Or you can say VSU is congruent to angle TUW. WT is the same thing. STUW. The only thing that matters when naming the angle is that the vertex is in the middle. So you can have more than one. All right, guys, so the next thing I'm going to check is that we can complete some proofs. I might need to make this smaller. Okay, guys, to help you make sure you can fill in your proof correctly, because we do eventually going to ask you to do one all by yourself, and when that happens, the order can vary. Our first step is always to mark the diagram. So take your given, mark it, and your known fact. So it says that it's parallel. This is parallel to AR. How do I show that? Arrow. So put an arrow. Also mark the other given, which is angle D is congruent to angle R. Now, if I have parallel lines, it's your responsibility to mark alternate, interior, or corresponding. That is a conclusion that you should be able to draw from having parallel lines. So, which one can I mark? Okay, so here, all right, there and there. I'm assuming that's what you mean? Yeah, DTA. Yeah, those are where the alternate interior are. Okay, now, any other known fact we can mark? The shared side, AT. So always start by marking your diagram with the given and known facts. Now we're going to take our marking and see if we can fill it in correctly. Now, let's just recap. Our first step should be a given, right? That's right. What's our last one? Well, we prove. So if we come down to step 6, which is our last step, that should be what we have. So DA is congruent to TR. Go ahead and get your first and last done, because then now we can just fill in the holes. All right, so we need to, right here, our reason is alternate interior angles. What's our statement we can make? Okay, I'm going to say DTA, but it's the same thing. I know what you meant. Is congruent to angle RAT. So, yeah, I would rather you do that because sometimes you might have double parallel lines and you have to decipher between which ones you're naming. All right. What can I state now? A given. What's our given? Yeah, angle D is congruent to angle R. So that's our given. Then we have the statement segment TA is congruent to AT. Yep, reflexive. POC, property of congruency. All right, so it says we're proving using angle, angle side. What? There it is, angle, angle side. So what can I state? Yeah, we should be doing triangle. Yeah, triangle DTA or triangle RAT. Triangles are congruent using angle, angle side. And then we already have our last step. Yes.
Is it okay to put AT instead of TA on the DAT?
If you did AT, then you have to have TA here. You just got to make sure the order matches. All right, the second one, I need you to kind of walk through it with me. Okay. Let's go ahead and mark the given and known fact. So the first thing is they're talking about triangle. And I'm going to highlight that. Oh, no, let's just do this. Triangle GSE is this triangle here. Okay? And then triangle STG. Or no, STG. So ST and then G. I'll scroll it down just a little bit. Okay, right there, do y'all see that these two triangles are overlapping? Do they share anything? I'm sorry, I need to scroll this up. Do you see they share? Hopefully we share right here where the blue and the gray are together. They shared that. Okay, they share that side. All right, I'm also going to mark that angle ESA and TGA are congruent. So ESA, oops, ESA is here, and then TGA. There we go. All right, so are we okay on that part? And then what? Our statement here, prove SA is congruent to GA. That should be our last statement. So go ahead and let's put that in for our last statement. SA, segment SA is congruent to GA. What we're trying to prove should always be our last statement. Okay, so here's what I'm going to do, guys. And you might need to do the same, okay, just so you can see the relationship. I know the first one is given. We're starting off saying that the triangles are congruent, okay? So I'm looking at my triangle. This is my triangle GES, okay? We're stating that that is congruent to, here's my other one, and that's GST. Okay, so, and we already know off the bat, we saw that they shared GS, okay? So if we know that these two triangles are congruent, what other conclusion could you draw about them? Angle E and angle T would also be congruent. Does that make sense? You could do any of them, yeah. You could say E and T, you could say G and G, we know because they kind of share that one. Does that make sense? So we can do any of them. Now, are given the one that we're going to focus on because they want us to use the same angle, okay? We have to use the same angle. And we're trying to use the triangle. So here's where we're getting to. Where else is there an overlapping triangle that has the same angle? S, yes, here we go. All right, so I'm going to highlight it. Two different colors. Do y'all see that triangle? Okay. Then I go here. Yep. Y'all see that one? Here is the shared angle. Angle A is the same angle for the two overlapping triangles, SHE and GAT. I said SAE, okay, and GAT have the same angle A, overlapping. Okay, so here's my help and my hint for you. Remember, you have to look at your markings. We're trying to get a three-letter congruency. Right now, if I'm looking at my yellow triangle, I have an angle and an angle. What else do I need to prove that it's congruent? A side. Which side could I use? Not angle. Side ES. You would have to use side ES, guys, because I know ES right here is congruent to ST, right? From the congruency statement. So I know ES, and I'm going to mark it right there. So now that I see that, I know that the two triangles are congruent by angle, angle, side. Well, down here. So which side did we mark to show that they have in the same ES, right? So that's my CPCTC. ES is congruent to ST. Because that was given. They started off with stating that they were congruent. Yeah. Then another given statement. Angle ESA is congruent to TGA. Like, now let's name the same angle. Which angle did we say they shared? A. All right, so angle SAE This always happens. SAE is congruent to SAE is congruent to TAG or GAT. TAG. Okay. Yeah. Okay, so SAE, it's not gonna let me move it. I'm going from S to A to E, and then I'm going up from G to A to T. It's the same angle A. I didn't know. It's not angle SA. What is the name of the angle? SAE. I stopped. The board's not working anymore. Okay. No, SAE is congruent to TAG. Yes. Number 5. What goes in line 5? Yeah, AAS. Angle, angle, side. And then we're done. All right, so number 3, the third proof, you are doing the table at the bottom. You are marking the diagram. I'm stamping that. That's the last thing I'm checking before you leave, before we do it, like a little exit. Yes. You can only use it with right triangles. So that's how I know when to use it. And I have to have a hypotenuse marked to use H. No. Nope, it would not. Yeah. Mhm. Yeah. Number 4 of what? All right, let's check if you marked correctly. Start off with marking 1 and 2 are right angles because that was given. Then ST is congruent to TP, given. And then we should be marking shared sides because we see that and that's a known fact. So hopefully our second statement is ST is congruent to TP, segment TP. TR we want is congruent to TR. That was our reflexive. And then now I can prove that the triangles are congruent by its side angle side, not hypotenuse leg. In order for it to be hypotenuse leg, I would need the hypotenuse marked. This is your hypotenuse, and then it's not marked, so I can't use that. I can use side angle side. So, and then our last statement, now that I know the triangles are congruent, CPCTC. All right, so that takes care of our notes, which we're adding to our spiral. Just to recap, this is our table of contents. Make sure we add we have our list updated. And your homework tonight was this following packet. Okay, partial key on Emoto, partial, also some hints, a video explanation. Make sure we get this done. If you have any questions, come to tutorials.